In this ShowMe, I'm going to address two more multiplication properties of exponents. The first property is going to be the property of raising a power to a power, and the other one is going to be raising a product to a power. As always, you can interact with me at my blog at Poliquin.com. You can also use that blog to ask for help on homework. I'd be happy to provide that anonymously. First, let's address the power of a power. Here we have a to the nth power, and it's being raised to the nth power. The property states that if that happens, all you must do to proceed is multiply the exponents together. Let's take a look at what that means with an example. Consider b cubed to the sixth. Now, before we had this property, that meant that we were going to take b cubed times 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 b cubed. But our previous work tells us that when we have products of powers of the same base, we can just add the exponents together. So that becomes b to the 3 plus 3 plus 3 plus 3 plus 3 plus 3 power. And our work in elementary school told us that when you add 6 3's together, you're simply taking 3 times 6, and 3 times 6 is 18. So b cubed to the 6th power is b to the 18th. Now that we've verified the property as demonstrated, we don't have to do all of this anymore. And in math, unlike basketball, shorter is better. This property works equally well with negative exponents. Consider raising b squared to the negative 8 power. Well, our previous work tells us the first thing we have to do is write that power in the denominator of a fraction. Now we're back in a situation where we have only positive powers, and the work we just did on the previous screen tells us that all we have to do is multiply those powers together, and we're done. Of course, as soon as you've mastered a new property, the textbooks and lessons that you confront will challenge you to combine that with previous work. Shouldn't be a problem. To simplify this expression, m to the 4th to the 5th times m cubed, first, taking m to the 4th to the 5th power requires us to multiply the exponents. That's m to the 20th. M cubed is still there, of course, and now we can use our previous work to simplify and achieve the result m to the 23rd power, which is the answer. Consider this one. First, we need to rewrite our negative exponent, and negative exponents mean that the powers don't belong in the numerator of fractions, they belong in denominators. So this should be v to the 12th on the bottom. Well, now we have a situation where we have 2 v's on top and 12 v's on the bottom. Two of those can go away. You end up with 1 over v to the 10th. Another way to look at this problem from the very beginning was to go ahead and multiply the negative exponents. Take v to the 4th times take 4 times negative 3, get v squared times v to the negative 12, which is v to the negative 10, which in many textbooks, if they tell you to simplify, that means they don't want to see negative exponents, so the final step might also be to convert that back into a fraction. Either way, the best response in many courses is going to be 1 over v to the 10th. For me, v to the negative 10 would be a great response. Unfortunately, I'm teaching in one of the former courses, not the latter. The other property to introduce in this ShowMe is the power of a product property. This property says that if we take a product of two numbers, in this case a and b, and raise it to a power, say the nth power, what we're really doing is raising each factor of the product to that power. Let's take a look at how that should work. Consider 2y cubed. Note that the entire expression is being cubed, not just the y. So what we really have here is 2y times 2y times 2y. Well, we know that multiplication is both associative and commutative, and that means that it doesn't really matter which order I multiply these 6 numbers. Let's put the 2's together then, and the y's together. 2 cubed, 2 times 2 is 4 times 2 is 8, and then y times y is y cubed. The upshot of this is that I didn't have to do all this other work. I could simply take 2 cubed right from the beginning and get 8, and take y cubed, and I have my answer, 8y cubed. I'll speed things up, and once again, in math, unlike basketball, shorter is better. As before, any good course is going to hit you with a series of opportunities to show your knowledge. In this one, a number of ways to proceed. I like to take negative exponents and get rid of them right away, if you haven't noticed. And that would change this expression immediately into 3h to the 4th squared in the denominator of a fraction. From there, I'm quite comfortable applying the square exponent to each of the factors inside the parentheses. 3 squared is 9. H to the 4th squared requires us to apply the other property, the power of a power. We should multiply the exponents. 4 times 2 is 8, so we have 1 over 9 h to the 8th. Another way to proceed, of course, would be to say from the very beginning that we have 3 to the negative 2 times h to the negative 8. And then rewrite that, if desired, as 1/9 times 1 over h to the 8th, which inevitably leads us right back to the previous conclusion. Again, I don't really have a problem with an answer like this myself, but most textbooks, the word simplify implies that there won't be any negative exponents when you propose your answer. If that's the case, you're going to have to conform to that standard or the standards of your teacher. Here's a nice tricky problem for you. Someone gives you a problem like this. They're trying to determine whether you think that that 0 exponent applies only to the u or also to the 4. The only exponent that applies to everything in this expression is the 8. The 0 applies strictly to the u. We assume that u is not 0. If u is 0, this is undefined. But if u is not 0, then u to the 0 is 1. So what you have here is 4 times 1 to the 8th power, which of course is 4 to the 8th power, which is 65,536. I suppose that really didn't apply the property as we've expressed it here, but it did follow the rules of the order of operations. If we're going to apply the property, we would rewrite this as 4 to the 8th times u to the 0 times 8, and 0 times 8 is 0. Again, the 0 only applies to the u, and u to the 0, unless u happens to be 0, is going to be 1. Multiplying by 1 is boring. 4 to the 8th, of course, is still 65,536. And of course, when you're building up all these different properties of exponents, you can expect to see problems where all of them are applied at once. Consider this one. We have two factors, actually, c cubed to the 4th and 2c to the 6th squared. Treat them separately to begin with. C cubed to the 4th is a power to a power. Multiply the exponents. You have c to the 12th. The other expression, however, is a case of using a power of a product. So each part of the product, 2 and c to the 6th, is going to be squared. So we'll have 2 squared times c to the 6th squared. C to the 12th is done for the moment, can't do much with it. 2 squared is 4, and c to the 6th squared is c to the 12th. Now to complete the process, 4 should be listed first. We usually list our coefficients that we know first, and then all of our factors, which are unknown, and which in this case is 24 different c's. So we have 4c to the 24th. Of course, since negative exponents are often strange characters, if not entirely new, to pre-algebra and Algebra 1 students, there has to be a problem involving them. Let's take this one, and take it carefully. Again, we have two factors. 5pq is being squared, and 5p to the negative 4th is being cubed. we should do those exponents first. So we have a power of a product in 5pq squared. So 5 is squared, p is squared, and q is squared. For the other factor, 5 is cubed, and then p to the negative fourth is cubed. The next step is to simplify as much of this as we can and start putting things in the correct places. 5 squared is 25. P squared, Q squared is just that. 5 cubed is 125. And then P to the negative fourth cubed is P to the negative 12. A couple ways to go here. We can go the way I often go and move the p to the negative 12 to the denominator. Or we can just go ahead and add the exponents now. First of all, 25 times 125 is 3,125. For p squared and p to the negative 12, we should add the exponents. We get p to the negative 10. And then q squared is just q squared. Finally, then, if you have to do, as the students in my class have to do with their book, and eliminate all negative exponents, your final answer is 3,125 q squared all over p to the 10th. I hope you find all these examples illustrative, and I hope that they correspond well to what's in your books. Again, if it doesn't, you can always query me personally for free and anonymously at MikePoliquin.com.